All right, now that we know the difference between a relation and a function and how to write function notation, we're going to take it the next step and start adding and subtracting polynomials and functions. But first we need to talk about what those words mean.
So, monomial is an algebraic expression containing one term. So, for example, x to the second or x to the third divided by 5.
A lot of you might be going, but x to the third divided by 5, isn't that two terms? Remember, terms, which are nomials or monomials, can have a multiplication and division within them. They are separated by addition and subtraction.
Polynomials are an algebraic expression containing two or more terms. So for the example, it would be 3x to the fourth plus 7x to the second minus 5x minus 6. And since we have addition, that's when we get into two or more terms and subtraction.
Now, there are certain types of special polynomials that have their own special names, but we'll get into those in a later unit. So, let's start by working with adding polynomials. So it's combining like terms. Parentheses are really just to separate out the two different polynomials that we're adding together. They really serve no other purpose because since we're adding, we just start combining like terms. We got 6x cubed and 4x cubed, which gives me 10x cubed. Remember, when you combine them, the numbers combine, the last names or the variables do not change with their powers. We've got negative 7x squared. I like to keep the symbol in front of it, but there are no other x squareds. So we've got minus 7x squared. Then we have plus x and plus 5x, which gives me plus 6x. And then we got this lone plus 1 on the end. So 10x cubed minus 7x squared plus 6x plus 1 would be our solution. Now let's take a look at subtraction. That's where the parentheses come in handy and are very important. When we have a quantity minus a quantity, remember, we're subtracting this entire quantity. That means we have to distribute that negative or that minus sign to everything and rewrite. And when we rewrite, then we can drop the parentheses. So we've got 7x cubed plus 3x squared plus 4 minus 10x cubed minus a negative 2x squared, which is plus 2x squared, and minus 4x. Then we can start combining like terms. Now, standard form, highest variable to the highest power goes first. So we've got 7x cubed minus 10x cubed, which is negative 3x cubed. Then we've got 3x squared plus 2x squared, which is plus 5x squared. Then we've got minus 4x with nothing else. And finally, we have this plus 4 to tag along on the end, which gives us our final answer of negative 3x cubed plus 5x squared minus 4x plus 4.
So just another reminder, when we subtract, we have to distribute that subtraction or the sign in order to get rid of the parentheses.
Right. And once you do that, then you can get rid of the parentheses. Finally, this is where we are talking about adding and subtracting functions. So we've got the function f of x equal to negative 7x squared plus 12x plus 2, and g of x equal to 7x squared minus 5. It says find f plus g of x. What this really means is we're going to take f of x and we're going to add to it g of x. So now we can substitute in f of x is negative 7x squared plus 12x plus 2, and g of x is 7x squared minus 5. Now because we're adding, parentheses don't play a factor and we can start combining like terms. We've got negative 7x squared plus 7x squared, which cancels. And then we've got 12 plus 12x with nothing else, so we'll put a 12x on the end here. And then we have plus 2 minus 5, which would be minus 3, giving us a final answer of 12x minus 3. The second part is f plus g of 2, which really means f of 2 plus g of 2. There's a couple different ways to do this. Because we just found out what f plus g of x is, right here, we can just substitute 2 in for x there. But if you didn't know that, you would have to replace all of the x's in f of x and g of x with 2, and then do a whole bunch of number crunching. I'm going to go the shorter route, and I know that that means I'm going to take 12 times 2 plus 3, because I already, sorry, not plus 3, minus 3, because I know that f plus g of x, we've already established, is 12x minus 3. Well, 12 times 2 is 24, minus 3 gives us a final answer of 21. And finally, we have f minus g of x. And so what we're going to do is, this really means f of x minus g of x. Remember, the first way is just a shortcut. You can write it either way. So then that means that I'm going to take f of x of negative 7x squared plus 12x plus 2, and I'm going to subtract the entire quantity of 7x squared minus 5. So as you probably guessed, we need to distribute that minus sign, which gives me negative 7x squared plus 12x plus 2 minus 7x squared minus a negative 5, which is plus 5. So now I start looking at combining my terms. I've got a negative 7x squared and a negative 7x squared, which is negative 14x squared. I've got a plus 12x, and I've got a plus 2 and a plus 5, which is plus 7, giving me a final answer of negative 14x squared plus 12x plus 7. So really not extremely difficult. We've already been doing a lot of this stuff. You just need, the big catch is substituting correctly. Now if it had said g minus f of x, we would have had to flip the terms around and we'd be distributing the negative into another value. So just remember to distribute that negative or the minus sign, and then make sure you're combining your like terms and not changing those variables when you combine. So now I want you to give it a shot. I've got these two, one subtracting and one adding. And then I want you to take this value, these f of x and g of x functions, add them, then add them and evaluate them at 3, and subtract them. And as always, bring your questions into the class.